Alrighty, so I'm going to go through a few examples of negative exponents, and then we'll jump in and do a couple of homework problems, and then you'll be good to go for today, okay? Alrighty, so negative exponents. So sometimes when you have a division problem, it usually happens when you're doing a division problem. Sometimes power to a power, like what we have in our homework. You end up with an exponent that's negative. So let me give you an example. How about, what if you had like x to the 5th over x to the 7th, like that? So we would do like we've been doing the past couple of days. We would subtract the exponents, and you'd put the x down, and it's always top minus bottom, 5 minus 7. Well, 5 minus 7 is a negative. It's actually -2. And so it's not proper to answer with negative exponents. So mathematicians have, that's one of their rules, that, you know, you just can't have your answer have negative exponents. So to fix that, we rewrite the answer so that it has a positive exponent. And so when you watch the Edpuzzle video, they do a really nice job explaining what happens. So negative means like opposite. So you have to do the opposite operation. So right now, well, I shouldn't say opposite operation. I should say, well, yeah, I guess it's opposite operation. That's how they explain it in the Edpuzzle. So right now, this is x to the -2. To get rid of the negative, you are going to move this whole thing down into the denominator of a fraction. And then the negative is going to get thrown away, and it's going to become a positive. So it kind of, if you could think of it like up here, it went to the opposite position. It like went down into the bottom of a fraction. So opposite position. And then you throw away the negative, so it just becomes +2. And there's nothing up here, but there's really a 1. So your answer becomes 1 over x to the +2. And then you're good to go. Okay? So what do we have to do to change it to positive? Let me write this out. To change a negative exponent to a positive exponent, move the term to the, I'm going to say opposite position, which in this case is the denominator. We move it down to the denominator and throw away the negative. They say that in the video. Oh, somebody joining our call. They say that in the video, and I really like that. Kind of like that idea of like throwing it away. Throw away the negative. Okay. I would absolutely, let me fix it for you. I would absolutely write this down somewhere, or let me, if I can arrange this, there you go. Take a screenshot of that and save it or something, because that's an important concept for today. That is what we are learning and practicing today. So I'll give you a minute to either write it or take a screenshot of it. Hi, Anthony. We're just starting the notes. So if you want to take a screenshot of what I wrote down, that's all I've gone over so far. Okay, so I'm going to move on. Okay, that'll still be up there for a little bit, but I want to do a few more examples with you, practicing this with numbers and also with variables. Okay, all right, so let's say we had 3m to the -2 power, like that. So it's very important that you recognize that this -2 goes with this m. And you're probably thinking, well, yeah, of course it does. But it doesn't go with the 3. The 3 has its own exponent, which is a little 1 there, okay? If there were parentheses around the 3 and the m, then we would have to distribute this -2 to each of their exponents, but there's no parentheses in this problem. So the -2 only goes with the m, okay? So our goal here is to rewrite this example with a positive exponent. All right, so watch what we do. I'm gonna put my equal sign. The 3 is raised to a +1. There's nothing wrong with this one. This doesn't have a negative exponent. It's +1. It's just fine the way it is. So you're just going to write the 3 down. If you want to put the little 1 there to like remind you that it's okay, you're welcome to, okay? But we know 3 to the first power is just 3. So you just recopy that one because there's nothing wrong with that. The m to the -2, that's the one that we need to fix. So we're going to draw a fraction bar. We can do it right underneath the 3. You don't have to put it over to the side. You can do it all in one, which is really nice. So put a fraction bar and then put the m down into the denominator and throw away the negative. So this will become a +2. So now this would be 3 over m to the +2. And now you are done. That's perfectly acceptable and correct and proper notation. Okay. So I wanted to go over an example that had something with a positive exponent and something with a negative exponent to show that the only thing that moves down into the denominator is the one that has the negative exponent. And then you throw the negative away. Any questions so far? Let me know if you're A-okay. Give me like, there we go. All right, cool. Cal, you okay? Awesome, thanks. All right, good. So let's move on. Let's do another one. So let's say you had a to the -4th, b to the 3rd. Okay. All right. So once again, a and b are 2 different letters, so we cannot combine those exponents. You can only add those exponents if you have the same base, and we don't have the same base. We can't multiply them because this is not power raised to a power, so we're not doing that. The only thing we have to do is just rewrite this so that it doesn't have a negative exponent. So the a to the -4th, that's the one that we need to take care of. So you're going to make a fraction bar. You're going to have a lot of fraction answers in this one. And you're going to move the a to the fourth down into the denominator and throw away the negative. The b to the third power is fine because it doesn't have a negative exponent. So you just rewrite that and it goes in the top. Okay? The only things that go down into the denominator are the ones that have negative exponents. Everything else just stays right along the top. And that's your answer. Okay. Now I'm going to give one for you to try. So try this. I'll give you like a minute or so, and then I'll go over it. How about, what do I have here? How about this? Okay, try that problem. So you want to simplify it with what we learned yesterday, and then write it in proper notation. When you're ready to go over the answer, give me like a thumbs up or a check mark. Cool. All right, let's do this. So this is going to become h to the 2 minus 7, which is going to be h to the negative 5th. Now, it's not proper to leave your answer with a negative exponent, so we fix it. We're going to put it into the opposite position, which is down in the denominator, and you're going to throw the negative away. So your answer should be 1 over h to the positive 5. Okay? How many of you got that? Great. Awesome. Okay, so now you're ready to move on to something more interesting. All right, so let's do, how about something like this? And we're going to work our way up to the ones like the homework. So I see I got to pick a few here that are like the homework. Looks like we need to do some power raised to a power because that's the homework is looking like it's favoring that. So let's do something like this. 8p to the 5th raised to the, well, let's just like start it out here. Raised to the positive 2. This one doesn't have negative exponents, but it's just a good one to review, power raised to a power. We'll do that first. All right, so remember how to do this because it's been like a little while. Remember this 8 has an exponent that's a 1. So you are going to distribute this 2 to each one of those exponents. So this will become 8 to the 1 times 2, p to the 5 times 2. Excuse me. All right, so this will be 8 squared p to the 10th. And then we can simplify 8 squared, right? We know what that is. That is 64 p to the 10th. Okay, so that's just review. Now we'll throw some negative numbers in there. Let's say that you have x squared y to the 3rd raised to the negative 2. So you're going to do the same thing that you did in the last example. Distribute the -2 to each one of those exponents. So this becomes x to the 2 times -2, y to the 3 times -2. Well, that's going to become x to the -4th, y to the -6th. Both of those have negative exponents, so we have to fix both of them so that they're in proper notation. So you're going to make a fraction bar, and then you're going to move the x to the -4th down into the denominator and throw away the negative. Move the y down to the denominator and throw away the negative. And then it looks like there's nothing up in the top, and we can't write a fraction with just nothing up there. So there's actually a 1 up there. And this is your answer. And we can't go any further because we have 2 different bases. And so we cannot combine these exponents. Okay? Okay, so that's a bunch of examples. Let's jump into the homework so that way we make sure that you guys are all set for today. Let's see, I will try to have it up on the screen the best that I can here. Looks like there are a bunch of problems today, lots and lots, but we need that kind of practice. So let's do, I don't know, we'll do a bunch of them together and then I'll just let you go for the rest of the day. If you have questions, you can message me. All right, so starting with number 1. X to the -7th. So there's not a whole lot that we can do with this. We just need to write it in proper notation. So that is going to mean moving the x to the 7th down into the denominator and throwing away the negative sign. Don't forget to put a 1 on the top, otherwise your answer is incomplete. Number 2, you have 5x squared y to the -3rd. Now, don't forget, like what we did in the examples before, this 5 right here has an exponent, even though it's not written. It's understood to be a 1. So there's no more simplifying, like we can't combine like terms or anything. This is as simplified as it can get. But we need to take care of the negative exponent. So everything with a positive exponent just stays put. The one with the negative exponent, you move down to the denominator. So this will be 5x squared, and then put the fraction bar, move the y down to the bottom, and throw the negative away. Okay. All right. Let's look at number 3. I can't quite see it where I have my sheet. Here we go. So this one is -4, a to the -2, b to the -2. Now, this one's tricky, and I usually catch students on this kind of problem because they see lots of negative signs. So they think they have to do something with all those negative signs. Do what we did in the last problem. Remember, this -4 right here has an exponent. It's a 1, okay? And the rule is that the only thing that you fix are the ones that have negative exponents. That -4 doesn't have a negative exponent. It just happens to be like a negative number. Negative numbers are okay. You can have negative numbers in your answer. You just can't have negative exponents in your answer. So this one's a trick, kind of. This -4 is okay the way it is. You don't need to move that anywhere. Just bring it over like that, because it has a positive exponent, so it's fine. Now draw the fraction bar. Move the A down to the bottom and throw the negative away. Move the B down to the bottom and throw the negative away. That's as far as we can go because you have two different bases, and that's your answer. And that -4 is perfectly fine in the answer. It's not an exponent, so it's just a -4. Okay? Okay, I hope so. Let me know if you have a question. Number 4. Okay, so this is AB squared raised to the -4 power. So this is a power raised to a power. So you put a little 1 right there. The more colors that you have, the better, okay? I like to use as much color as possible. All right, so we're gonna distribute -4 times 1, -4 times 2. So this would be A to the -4, B to the -8. All right, now we're not done yet because we have negative exponents. So we're not allowed to answer with a negative exponent. We need to make this proper. So both of these have negatives. So we are going to make the fraction bar. And they're both going to go down into the denominator and throw the negative away. And the top needs to have a 1. All right. Okay, let's look at number 5. Number 5 has a -8 and then a parentheses, x to the -3, y to the 4th, close the parentheses, raised to the -5th. Now, this also is one that looks like a lot going on. There is a lot going on, but be careful, okay? The -5 out here is only gonna go to the -3 and to the 4. You don't do anything with this -8 and the -5. If you did need to do something, the -8 would be in the parentheses with the x to the -3rd and the y to the 4th, but it's not. So that means that it does not have anything to do with this -5. Okay, so it does have an exponent. It's a 1, a positive 1, I might add. So it doesn't have a negative exponent, so it's fine. So we will rewrite it as -8. If you want to put the little 1 there just to remind you that it's okay, you could. Now we're going to do our power raised to a power. So this will become x to the -5 times -3. Well, a negative times negative is a positive. So this will be positive 15. And then y to the -5 times 4, that is -20. So it looks like we have something we need to fix. The -8 is okay because it has a positive exponent. There's nothing wrong with this. The x is okay because it has a positive exponent. The y is the one that needs a little bit of help. So we rewrite the -8. You rewrite the x to the 15th, make a fraction bar, put the y down in the bottom, and throw away the negative sign. Okay? That was a good one. I'm glad that we were able to do that one together. All right. I'm going to do number 6 with you, and then I'm going to jump down to number 12. All right. So number 6. For number 6, you have 3x raised to the -3rd power, like that. So as long as you're organized and patient with yourself, put the little 1 right there, put the 1 with the X, keep it easy. We're going to distribute the -3 to the 1 and to this 1. Goes to both of those terms because there's parentheses around both of those terms. So this becomes 3 to the -3rd x to the -3rd. So both of those terms, both of those, the 3 and the x, both of those bases, both have negative exponents. So we got to fix that. So make the fraction bar, move it to the denominator, and throw the negative away. Put the x in the denominator and throw the negative away. Put a 1 on the top. Now, I would like to continue simplifying this because 3 to the 3rd is just some number. Like we could type that into our calculator or do it in our head and simplify this a little bit more. So this will be 1 over 3 times 3 times 3, which is not 9, right? It is actually 27 x to the 3rd. Now you're done. That's a good answer. Okay. All right, I want to jump to number 12. Maybe skip a few lines on your paper if you're doing these right along with me. And I noticed in number 12, there's a plus sign there. So I want to make sure we do that one together. I don't think any of the other ones have a plus sign. So that's kind of the oddball on here. So we're gonna do it together and see how it turns out. So this is x to the 3rd, y to the 6th, raised to the -2 power, plus x squared, y to the 4th, raised to the -3rd power. This is a good one. I like this one. All right, so, okay, let's do what we need to do here. You're gonna do power to a power, so you're going to multiply these and distribute like that. So let's see, I get x to the -6th, y to the -12th, plus x to the -6th, y to the -12th again. How about that? So they're not going to cancel each other out. Sometimes we see that with the negatives and it's like, oh, I think that's just going to be 0. It's not going to be 0. All right, let's rewrite it in proper form. So this is a negative exponent. This 12 also has a negative exponent. So we're going to go down to the denominator, throw away the negative, write the y, throw away the negative. There's a 1 on the top right here. Plus fraction bar, same thing going on here. Move it to the denominator, throw away the negative. Move this to the denominator, throw away the negative. Put a 1 on the top. So they're like identical fractions, and we're adding them together. So you have to go way back to when you first learned how to add fractions and think about what you have to do when you add fractions. Fractions, when you add them, have to have a common denominator. Well, we have a common denominator. So when you add fractions, you keep that common denominator. So you don't add or do anything with the denominator, okay? You just keep it the same, combine it down to one fraction. And then what do we do with the numerators? We add them. So 1 plus 1 is 2. So this actually combines to 2 over x to the 6th, y to the 12th. So that was like a challenge one. You won't have to worry about that on the test for this. Mostly just all the other ones that we did on the homework. But I saw that one and I was like, oh, we should talk about that one because you're still doing the same properties. It was just this last step that maybe you hadn't seen that before. So, alrighty, everybody. What I'm going to do is leave the call open. And if you have any questions or anything for me, you know where to find me. Holler and ask me lots and lots of questions. If you are feeling good and confident, you are free to check out and have a great day.